This video covers section J, the annuities module. It's the last video for this module. In this video we're looking at amortization of loans. Now the term amortization refers to loans where each payment is made up of principal and interest components. Now ordinary housing mortgage loans, which usually have a term of many years, are the common use of amortization. Early in the term of the loan, the amount of the principal outstanding is large, hence the interest component of the loan is high and the amount paid off the loan is small. As the loan progresses, the amount of principal paid each repayment increases and the amount of interest decreases. The operation of the loan can be shown using an amortization schedule. So let's see what I mean by that. Here it's got a loan of $100,000 is being considered over a term of 10 years at an interest rate of 9% per annum. So I've got a loan of $100,000, 10 years, 9% per annum, and it's monthly repayments. Number 1, determine the monthly repayments. 2, prepare an amortization schedule for the first 6 months. C, determine the total amount of interest paid. And D, determine the amount of principal paid in the 25th month. So if we think about our timeline, how I've created this timeline, I know I've got 10 years, but it's monthly repayments, so that's 120 months. So that's why I have it going up to 120. The other thing you can see is we're starting off with this $100,000 loan. So the $100,000 is at the beginning, it's a present value. And our repayments are made each month. Okay, so that's the first step, just getting your head around that whole question. And I think also the timeline can help kind of figure out what you're looking at. Are you looking at an ordinary annuity? Are you looking at an annuity due? Things like that. I should also point out, because we're looking at a loan, repayments on loans are made at the end of the month, so it's an ordinary annuity. Okay? So you get the loan and then you start paying it at the end of every month. Now because our lump sum's at the beginning, as I've already mentioned, that's why it's present value. So we know we're looking at present value of an ordinary annuity. It's a hard word to get my tongue around. So determine the monthly payments. Our amount is $100,000. We have an interest rate of 0.09%. Or I could have written 9%, I've just put it as 0.09, but it's per month, so we need to divide that by 12. So 0.09 divided by 12 on your calculator, get a nice decimal, so 0.0075, and our N, as I've already stated, was 10 times 12, which is 120 months. Now it's present value of an ordinary annuity, so we have A equals R, 1 minus 1 plus I to the negative n all over I. We need to know what our repayments are, so we need to change the formula around. So it's like that AI multiply by that. That would leave all of this, so then we're going to divide by everything but the R. And that ends up being R. Okay, so from there, I'm going to put the R out the front. I end up with 100,000 times by my 0.0075 all over 1 minus 1 plus 0.0075 all to the power of negative 120. When plugging in your calculator, remember you need brackets. Okay, so you're dividing all of the top divided by all the bottom. You'll get your repayment is approximately $1,266.76 per month. So therefore, monthly repayment is approximately $1,266.76 per month. Okay. Next it says, prepare an amortization schedule for the first 6 months. This is where things get complicated. You're never going to be expected to do this in a test situation or in a module, or maybe in a module test, but never in an assessment test. Now because of that, I'm not actually going to go through this in the video, I would bore you to death. I also think that how it's explained in the textbook is very straightforward. So for 1 month, you know that your principal outstanding is at 100,000. You've got interest of 0.0075. So your interest is 100,000 times that 0.0075, which is your $750. From there, you know that you need to pay $1,266.76 per month. We just worked that out in the first part of the question. So our principal paid off the outstanding principal is our $1,266.76 minus the $750, which is the interest. So that gives us our $516.76. From there, our principal outstanding is going to be our $100,000 minus that $516.76, because that's all we've really paid off the principal. We have to take into account that interest. So then when you get to your next row, you've got that $99,483.24, which is the last cell, the principal outstanding, and then you go through the same thing. So your interest per month now is 0.0075 times by that amount. And then you keep working your way along. So next, let's look at the total amount of interest paid. Now, the total amount of interest paid over the 10 years of the loan is calculated by calculating the total paid in repayments. So repayments were approximately $1,266.76. So total repayments, it's going to be $1,266.76 times by 120, because that's how many payments we make. So that gives us $152,011.20. So what I need to do now is go, well, I had a loan of $100,000, didn't I? But my total repayments is $152,011. Sorry, $152,011.20. So what we need to do now is go, well, $152,011.20 minus 100,000 gives us $52,011.20. Okay, so that's the total amount of interest paid. Okay, the total amount of interest paid is $52,011.20. Pretty scary, isn't it? I mean, especially when you think that's only on $100,000. Next, determine the amount of principal paid in the 25th month, and that should be principal AL. Sorry about that. So the amount of principal outstanding at the beginning of 25th month. At the beginning of the 25th month, we've already made 24 payments. So 24 payments have been made. That means that we've got 96 months left on the loan. Okay, now using the present value of an annuity, the amount of principal outstanding is going to be given by our A equals R, 1 minus 1 plus I to the power of negative n, all over I. Plug in what we've got. Our repayments, $1,266.76, 1 minus 1 plus 0.0075 to the power of negative 96. That's because we've got 96 months left of the loan, all over 0.0075. Okay, from there, plug that in your calculator and you get $86,467.06. So the amount of principal outstanding at the beginning of the 25th month is going to be that $86,467.06. Now, because that's the amount of principal outstanding at the beginning of the 25th month, the amount of interest for the 25th month is going to be on that amount. So interest will be $86,467.06 times by our 0.0075, which gives us $648.50. So from there, the principal paid, and I'll spell it correctly now, is going to be the $1,266.76, our repayment, minus that $648.50, that interest, which gives us $618.26. And that process is going to repeat each month until the loan's repaid. Okay? So what now? Exercise J1 of the textbook. It is the last exercise, so please remember to revise, review, do the sample module test and also the module test. Remember that sample test gives you a really good gauge on what your actual test is going to be like.